At the end of watching the video, a student would be able to design parallel adder circuit using full adders and to design parallel adder subtractor circuit using full adder. In order to add two 4-bit numbers, we need 4 full adders in parallel with carry of previous stage added to the next stage carry input. While for carry input of first stage will be 0. For the two 4-bit numbers, the arrangement is shown in this circuit diagram, where Cin is equal to 0 at the first full adder stage and Cout of the first stage is applied to the carry input of second stage. In this way, the 4-bit sum output is S3, S2, S1 and S0 and final carry output is Cout. We can also utilize full adders for subtraction of two numbers. A minus B can be said as A plus of minus B, and we remember that 1's and 2's complement are used to represent negative numbers, and with this representation subtraction problem is converted into an addition problem. It should be noted that 2's complement is preferred over 1's complement in implementations as it has single representation for 0 and it does not require addition of resultant carry to the sum. Thus, A minus B can be said as A plus 2's complement of B, and 2's complement implementation can be further done by using 1's complement and adding a 1 to the output. Thus, A minus B is equal to A plus 1's complement of B plus 1. The result of A minus B will be in 2's complement form. Thus, two numbers subtraction can be easily effected using full adders. Here the two 4-bit numbers, the second number B3, B2, B1 and B0 has to be subtracted from the first number A3, A2, A1, A0. The second number, the negative number, is complemented using an inverter that results in 4-bit full adder. It is addition of A plus 1's complement of B and a 1 is applied to the carry input so that it is A plus 2's complement of B. The output S3, S2, S1 and S0 is the sum output of this addition of problem and C output is the carry. And the result is shown in 2's complement form. The two circuits, addition and subtraction of full adders, can be combined into a single one by using a control M. If M is 0, then it is an addition problem of two numbers, while if M is equal to 1, it is a subtraction problem. For subtraction, we require second input to be complemented and carry input applied as 1. For addition problem, we require second input applied as it is and carry as 0. So when M is equal to 0, the XOR output will be equal to input B and carry will be 0 at the first stage. So the circuit will act as a 4-bit parallel adder. While if M is equal to 1, then carry input at the first stage will be 1 and output of XOR gate will be equal to B complement. That means it will be A plus B's complement plus 1. That means A plus 2's complement of B. Thus the circuit will act as a subtractor, full subtractor with output as in 2's complement form for subtraction operation. The references for the video is Digital Logic and Computer Design by Maurice Mano of Pearson Education India and Digital Electronics by G.K. Karate of Oxford University Press.